Today we worked on adding mixed numbers. And the basic idea when we add mixed numbers, what we basically want to do is, let's say we have this for an example, 2 and 2/5 plus 3 and 2/5. What we talked about is first looking at the fractions, making sure they have a common denominator, because they have to have a common denominator or you can't add them. And then we're going to go ahead and we'll just draw our line, and since we're talking about fifths, we'll go ahead and put that there. And we'll look at our numerators, and 2 plus 2 is 4, so we'll just add those fractions together, just like that. And then we'll look at the whole numbers. 2 plus 3, that's 5. So the answer in this case would be 5 and 4/5. What got a little tricky, though, we'll erase what's here really quickly. What got a little tricky is when we had something like this. We had 5 and 3/4 plus 2 and 2/4. Same steps at the beginning anyway. We look at the denominators. We see we have a common denominator, so we can go ahead and add. We know we're talking about fourths. And then we are going to go ahead and add our numerators. 3 plus 2, that is 5. So our fraction is 5/4. Our whole numbers would be 7, so 7 and 5/4. But we just can't leave a fraction as an improper fraction. So that has to be converted from an improper fraction to a mixed number. And we talked yesterday about several ways of doing that. The basic idea, though, is to say how many groups of 4 can you take out of 5? In other words, if I had 5 counters here, how many groups of 4 counters could I take out? Well, I could take out one whole group of 4, and I'd have one left over. Another way to think of it would be just division. It's simply 5 divided by 4. When you see a fraction, that's really what you're saying is the numerator divided by denominator. So 5 divided by 4. How many times can you take 4 into 5? And it's one time. Then we multiply that, we subtract, and there's one left over. So we have put that 1 on top of the 4, so then again we have 1 and 1/4 is another way of thinking of it. We also then yesterday talked about pictures. And if you had 5/4, we would take a circle and divide it into fourths. We'll just take 2 circles. And we'll color in 5 of the fourths. 1, 2, 3, 4, and we have to go over to this other one. How many did we color in? We colored in 1 whole and 1 out of the 4, so 1 and 1/4 is another way of looking at that. However you choose to do it, I think the easiest way, and ultimately what would be best, is if the kids could get themselves to say, how many groups can you take out of 5? Well, you can take one whole group. What's left over? If you take 4 away from 5, what's left over? Well, there's 1 left over. And we're talking about fourths. So it's 1 and 1/4. And then we can't forget, though, to add that to the whole number that's already there. And, of course, you just add your whole number. 7 plus 1 is 8, and then your fraction is just 1/4. So the answer for that would be 8 and 1/4. Let's look at one more. Do a little erasing here. I'm sure there's a quicker way to do this, but right now I don't have time to look for it, so because I want to get through this and not have to do it again. Okay, so let's say we had 4 and 3/5 plus 3 and 4/5. Same thing, common denominator, so we're good on the fractions. We're just going to add our numerators. Yes, we see that it's an improper fraction, but let's get our whole number there first. 4 plus 3 is 7. 7 and 7/5. That's a problem. We're going to say how many groups of 5 can you take out of 7? 1 whole. If you took that one group of 5 out of 7, there would be 2 left over. They would be 2/5. You would add that, and you'd get 8 and 2/5 as your answer. And we talked about another way of doing it being to convert each of these mixed numbers into improper fractions, and that would, of course, be 23/5, and that would be 19/5. and then adding those. But the numbers got pretty big. I mean, you end up with 42 fifths, and you've got to do that division and how many groups of 5 are in 42. This method right here of converting to an improper fraction is going to work better when we're talking about subtraction, which we'll be doing next week, I believe. So it's just something to kind of tuck away in the back of your mind. It's why we practice converting from mixed numbers to improper fractions and improper fractions to mixed numbers yesterday. So hopefully that helps you see how to add mixed numbers, and that's it.